case, can we do l'hopital?
I'm perfectly well, thanks. I don't need to go.
No, Joe, hopital, not hospital. It's what we use when we can't quite determine the limit of a fraction.
Like this fraction up here?
Yeah, that fraction looks gnarly.
So look, as we make x closer and closer to 0, this e to the x will get closer and closer to equaling 1.
So then as we minus 1 from it, the top of the fraction will end up approaching 0.
And the bottom of the fraction, which is just x, will end up approaching 0 too.
Well, what's the limit then?
Well, we can't really say what 0 over 0 is. So this is where we'd use Hospital's rule, you see.
Hopital.
So give me a break, Donald. I'm not exactly French.
Brothers, please. L'Hopital's rule states that if the limit of a function over another function is indeterminate, like the 0 over 0 we just had, we can try to find it by working out the derivative of the top over the derivative of the bottom.
Yo, let's do it for that question from before.
Okay, so for the top, e to the x's derivative is still e to the x.
And minus 1 is just a constant, so its derivative is 0.
And for the bottom, the derivative would just be 1.
Oh, so now we got the limit of e to the x over 1, so just e to the x.
Exactly, and this is actually doable now. As x approaches 0, e to the x will approach e to the 0.
So the answer to this is 1, and that's the answer to our original question. Hallelujah.
Wait, so is that it? Is that hospital?
Yeah, but that was just the case where our first try gave us 0 over 0.
You can also use Hospital's rule if you ever end up with infinity over infinity.